Welcome back to the OrCAD X Capture tutorial series. My name is Adam Fuchs, and we've made it to part 4 of the video series, where we're finally going to finish up creating most of the other parts that we need for the power page and start actually placing them on the schematic and connecting them together. So for those of you that have been following along, please continue to do so with the files that you've been working on. And if you're just joining us or would like to continue working from where we are now starting, go ahead and download the supporting files and you can pick up right where we left off in the last video. So the first thing we need to do is actually add a couple supporting components that we're going to need for this page. Specifically, we need to add some capacitors and resistors to our library. I'm going to go into the Component Explorer here. In the meantime, between the two videos, I actually added a couple of categories here on the left side. If you remember in the previous video, we only had the IC category. What I've done is I've also added the capacitor category. And let me click edit here so you can see what the properties I've attached are. So there's height, value, tolerance, voltage, package, minimum temperature, maximum temperature, class, and temperature coefficient. I've also added a connector category. This one is very simple with only a generic name and a height. Actually, this needs to be set to value. I've also added a diode category. These are the properties. And you can go ahead and create these categories as well in your environment. Created also an inductor category. And finally, a resistor category. For this resistor, we actually want to set some of these as displaying on the schematic. So I'm going to go ahead and set those really quick. All right, so first things first, let's go ahead and add a resistor into our library. To do so, right-click on the resistor category, add new component. For these properties, let's go ahead and add some values of the specific resistor that we're trying to make. In this case, I want to make a 5.1k ohm resistor that's going to be used on our USB connector, which we'll add later. Not all of these properties are going to be exactly what they are probably if you were to look for this part on like DigiKey, Mouser, or whatever you use for procuring your parts. I am just quickly editing some of these values for the sake of this demo. For the value, let's go ahead and set that to 5.1k. We're going to say it's a 1% tolerant part, 0.25 watts. Voltage, we can leave that empty. Package, we're going to use an 0603, minimum of -40C to 125C. For our models, if you search in the symbols, you should find a resistor 1 schematic model that you can use. And for the footprint, you should be able to find an 0603 resistor footprint. Res 0603, click the checkbox and attach. For the part number, I'm going to set this as CDN-demo-0004. I believe this is our fourth part. And press save. So now we have our part. Oh, looks like I forgot to add a description. Let's go ahead and add a quick description here. Res 0603 5K10 1% 0.25 watts. There we go, we've added a description. And there's a couple other values that I also need to add. Now, rather than creating these each one by going into the resistor category and selecting new component, etc., I can select any existing part and simply duplicate it and edit the appropriate information. So for example, here this CDN demo 0004 resistor, I can do a right click, duplicate, and you'll notice that all of these property values have already been entered. The only thing I need to change here, for example, I want to make a 10K resistor, is I'll change the value to 10K. I'm going to leave the tolerance and the power as they are. And then also just change the description. So it says 10K0 and change our part number to increment. Go ahead and save that. I also need to create a couple more resistors, and we're going to do so just using the duplicate command. So I'm going to right click, select duplicate, and this is going to be a 1.5K. I also need to make 100K and an 86.6K. Okay, now that these have been added, I'm going to go ahead and add a connector. And feel free to pause throughout this so that you can also make these components in your own library. The part we're going to make is cdn-demo 9, connector category, and this part is USB type C. For the generic name, it's USB 4085-GF-A. For the height, let's just leave that empty for now. For the model, symbol, under symbols, you should find the USB 4085. Attach, and for the primary footprint, it should also be a USB 4085 footprint. Perfect. Let's go ahead and save that. Now we already have a couple components, so let's start placing them on our schematic, and we can start to add more parts into our library and our schematic as we go along. Jumping back into my schematic, I'm just going to highlight these components and use Control X, or you can use Edit, Cut. And we want these to be on their power page. I'm just going to paste them onto our power page. We also want to place that USB connector. So I'll go into my Component Explorer, select the USB connector, and place it. And let's grab our resistors. In this case, we want our 5.1K ohm resistor. I'll place it, and I want 2 copies of this. Now, those of you familiar with the USB Type-C connectors, there's actually 2 pins that we need to pull down to ground with these 5.1K ohm resistors, and those are pins A5 and B5. So what we need to do is draw a wire from the pins A5 and B5 on this connector to this component here. To start wiring, we can either go to Place, Wire, or use the W hotkey on the keyboard. So I'm going to press W, click on the pin, and then draw a wire to the target pin. In this case, it's this resistor. Now you don't always have to go from pin to pin. You can also click on any node or any empty space on the schematic and just click to add a vertex, double click, and press escape to finish placing the wire. And then if you want to, you can place or connect something here later down in the future. Now, as I said, these need to be connected to ground. So let's go ahead and add a power symbol through the place command, place, ground. And if we scroll down here, you can see that there's a couple different ground symbols. There's the ground, ground earth, ground field, ground power, ground signal. I'm just going to grab this regular ground, place it right there, and right there, and add 2 wires connecting those grounds. There's a couple other connections that we need to make here. For example, all of these mounting holes can also connect to ground. So let's copy this ground symbol, do Control C, paste it. And again, I'm just using the wiring command right now. If you want to move a component which you've already placed, simply click on it and then drag it. This way you can adjust, for example, what the wiring looks like. And then we also need to add some power nets to this USB connector. So pins A4, A9, B4, and B9 are our USB voltage. So let's go into the place, power, and let's see what symbols we have available. The one that I want to use is the VCC bar. It's just my personal preference, but you also have the VCC arrow, for example. I'm going to go ahead and place 2 of them. And we're going to connect A9 and A4 and B9 and B4. Now our net isn't actually called VCC bar. We can double click on this and change the name in this properties editor to plus VUSB. Go ahead and close that, and you'll notice that the name automatically gets changed. Or if you double click on just the text, you'll notice that the name can be changed, and the value here is currently VCC bar. Let's set that to also plus VUSB. So these two should now be logically connected. If we hover over these wires, you'll see the tooltip that says that this net is called plus VUSB and this net is called plus VUSB. Even though there isn't a physical wire between them, these power symbols act as sort of ports between one and another. And we'll be using some of these throughout the design as well. A couple more connections for this USB connector. This B12 here, that's actually a ground as well, and A1 ground as well. Let's go ahead and move this out a little bit. Having some issues selecting that. Let's just go ahead and delete that wire. There we go. And A12 and B1 are actually also grounds. And then we have our USB interface, which is the data plus and the data minus, coming out of pins B6 and B7, or A6 and A7 respectively. So let's go ahead and draw those on both sides of the chip. Now, because these aren't going to be connected to a power symbol like this, what we want to do is actually add a net alias to them. To do so, go to place, net alias, and I'm going to call this alias D_N, which is my B7 pin here, and D_P. And what that does is when you attach it to a net, that whole net will now be called whatever that net alias is. And now we actually want to add those same net aliases to pins A6 and A7. Place, net alias, DP will be on A7 and DN will be on A6. Okay, so we have our USB connector. The next thing that we need to do is draw the next stage in our power delivery system, which is the battery charging IC. Let's go back to our Component Explorer, and in our IC category, we're going to add a new part. And we're going to call this part, For the part number, it'll be CDN-demo-0010. For the generic name, we're going to use BQ21040, class IC, min temp. Again, we're just putting in some values here for the sake of demonstration. In our models for the symbol, there should be the symbol's BQ21040. We're going to select that, attach it. And for the footprint, we're looking for the SOT236. There it is. Go ahead and attach that. And for the description, we're going to call this a battery charging IC. Actually, I think this is a LiPo battery charging IC. Let's go ahead and place that part in our design right here. We can move these out of the way for now. Now this V in into this IC is actually going to come directly from the plus V USB. We're going to have some capacitors on here as well. So let's go ahead and add some capacitors to our library. Again, we're going to create one capacitor and then copy it a few times using the duplicate feature. I'm going to do new component. This is going to be a 1 microfarad capacitor. For the tolerance, we'll set it to 10%. Say it's 25 volts. Package 0603, min temp -40 to 85 C. Class, this is the discrete part. And a temperature coefficient, we'll say that this is an X7R. In our models, we have a capacitor symbol that we can use, Cap1. Let's attach that. And for the footprint, we want our 0603 capacitor. There should be a Cap 0603 footprint. Let's go ahead and attach that. For the description, this will be our Cap 0603 1 UF 25 volts. And we just need 3 more capacitors, so let's duplicate those really quickly. So this is a 470 picofarad 50 volt capacitor. I've adjusted the description and incremented the part number. Let's save that. And we're going to duplicate this one as well. This is going to be a 2.2 microfarad. $25 volts. Save that. And then last but not least, we have a 10 microfarad. So we want a 10 microfarad 25 volts. Usually uncommon to find them in this small of a package. I think you might be able to find an 0805 10 microfarad 25 volt. So that's just what we'll go with. We'll set this to 10 microfarads, 25 volts. Change the package here to 0805. And then in our models, we're just going to edit that so that the footprint is using the cap 0805. Let's go ahead and attach it. And click save. All right, I think these are all the capacitors that we're going to need for this page. Let's start by placing this 1 microfarad capacitor on this V-in pin. Now you'll notice that this capacitor actually has a voltage and a package value here that aren't being set. Let's just go ahead and make sure that everything is correct here. Here's why. So I made a mistake when I was creating the capacitor category. If we go into edit the category, You'll notice that I forgot to set the voltage, the value, the tolerance, the package, visibility on schematic setting. So for example, we would want to display the value of the property. Same thing with the tolerance, we might want it to show the value. In this case, if I look at the preview here, we want the value, the voltage, and the package. So I'm going to set those to value and save that. Now, this specific capacitor was created while the category was in its old form. If I look at the properties on the right side here, you'll notice that the value is still set to do not transfer. But for just this time that I'm placing the component, in the right side here, I can set the value to visibility value. I can set the voltage to visibility value and the package to visibility value, so that when I place it, it will display all of those. Now, I don't need to worry because once I change the category options, when I add a new component to that category, if I were to place new component, all of these would already be set for that new component, so I wouldn't have to manually change the visibility each time. That's just my little mistake that we're going to keep working with. All right, we need one of these 5.1K resistors on these pins here. And we need a ground symbol here and here. On the right side here, we want a 1.5K resistor. So we're going to go into our Component Explorer, resistor, and let's grab our 1.5K ohm. And this is going to come all the way from the output pin to the charge pin through an LED. Let's go ahead and add that LED to our library. Under diode, new component. Just to show what I was describing earlier, if I go to edit this category, currently all of these are set to do not transfer. I generally don't care too much about seeing these on a diode. But let's say that, for example, we want this maximum forward voltage to display. We can set that to value, save it, and let's go ahead and create our LED here. Let's add some properties. Volts, let's say 1.6 volts, rectified current. Again, these property values, I'm just sort of guessing here for the sake of time. 0805 LED, we'll have to double check that. Let's go into the models, symbol. It's SML. Okay, let's attach that. Here we're going to change this to SML-210MTT86. And then for the footprint, let's see if we have an SML footprint, or I'm going to really quickly look up what that footprint was. And I can see that it's a 0805. So let's go ahead and add just a res 0805 footprint to this. All right, we have added our diode. Let's go ahead and place it on our schematic. If I want to rotate a part, I can use R on the keyboard as a hotkey. I can also right-click and mirror the component, or again, select that rotate option from the right-click properties. In this case, let's go ahead and mirror it horizontally. Now, because we set that property to visible on the schematic, so the VF 1.6 volts, we set it to value. That property automatically came through on the schematic when we placed it. Let's go ahead and finish connecting it up here, and it's good to go. One other thing we need to add here is a connector. And we're going to just really quickly add in the generic name and add some models. And let's go ahead and place this battery connector right here. And it's going to be connected to this output pin, as well as a 10K resistor. There's our 10K. We're just going to make a little more room here, spread these components out, and we need to add also this ground to this pin right here. Now we can actually take advantage of these parts which we created earlier. Let's go ahead and move these over a little bit. So this MIC 5205 regulator is going to be supplying 3.3 volts to our microprocessor, and this 12 volt boost regulator is going to be supplying 12 volts to one of our peripherals, which we'll work on in another video. So let's go ahead and connect this up. You want a wire from this pin going to the input. Let's move this down a little bit. The enable pin, let's tie that directly to the input pin. And then we need a 1 microfarad capacitor on the input pin with a ground, as well as a ground right here. Now we can bypass this bypass pin with a 470 picofarad capacitor. That's basically for some noise reduction. We can also choose to omit that if we want to, but let's go ahead and add the 470 picofarad cap. And then finally on the output, we have a 2.2 microfarad output filter capacitor. Again, connected to ground on this other side. And then this here finally will be our 3.3 volt voltage node. So let's go ahead and place power. We want that bar, and rename it to plus 3.3 volts. Oops. Plus 3V3. Wonderful. Now we need to connect this 12 volt boost regulator. This basically needs this power from here coming into the input pin. there is going to be a 1 microfarad cap acting as an input filter. We also want an inductor between our V-in and switching pins. So let's go ahead and add an inductor. For the value, I believe this is a 10 microhenry that we're adding. I'm going to say it's 10% tolerant. Current 1 amp. 1 milliohm of DC resistance. The package is going to be, I believe, 0805. We'll double check that in a second. All right, for the model, I believe we already have an inductor that we can use right here. And for the footprint, we are going to use this inductor 0805. Let's place that on our page. Right there. Now the feedback pin is going to need a resistor divider, which is an 86.6k ohm resistor and a 10k. So let's place that. There's our 86.6. Place. And our 10k ohm. Let's see if we can copy one from somewhere else on the schematic. There it is. Paste it right there and add a ground node. Now you'll see I'm working pretty quickly. I'm just taking advantage of the different hotkeys. If you're not familiar with the hotkeys yet, don't worry about that. As you get more practice in the tool, they become more natural to use. This shutdown pin needs a 10k pull down to ground. And then we're going to add a net here, which is called LCD power enable. Place, net alias. Just like that. Okay, I believe we have one or two more things missing here. First of all, we need a capacitor on the output of our boost regulator. Let's go ahead and make sure that we include the actual voltage and package. I'll go ahead and fix these up in between the videos. And then we also have a power net here. This is going to be our 12 volt output. Plus 12 V0. We also need a Schottky diode. This is pretty specific to a boost regulator setup. So let's go ahead and add that Schottky diode. Component Explorer, diodes. Let's add a new component. I'll fill some of these in later. Let's go ahead and add a schematic model. This is going to be Schottky diode. And then for the footprint, this SOD123FL. Let's go ahead and attach that. So for the package, it's SOD-123FL. If I look at the diodes, I notice that here I set the forward voltage to set the value. So let's just set that so we have something to display on the schematic. We're going to say that this is 0.4 volts. Schottky diodes usually have a pretty low forward voltage. And let's save this part. Schottky diode, place right there. And I think we are more or less set with everything that we need on this page. So let me just review really quick. We have our USB Type-C connector with our battery charger. To move around the schematic like I am with these little arrows, go ahead and click the middle mouse button on your mouse and then simply move your mouse in the direction in which you want to pan the screen. Just making sure that everything is connected more or less how I expect it to be. And it's all looking pretty good. Okay, one more thing I need to add, well, two more things I need to add is these pins A8 and B8, I actually want these to be unconnected. Now by default, there might be some error checking turned on that will flag these as a warning and say, you're not allowed to have unconnected pins, go ahead and either connect them or set them as do not connect. Now, there's two ways to set them as do not connect. The first is to simply double click on the pin and select this checkbox, is no connect. Go ahead and close that. Or alternatively, you can go to place, no connect, and this little X will be hovering over your mouse. Click it on the pin which you want to set as no connect. The second thing we need to do is actually control a couple of these nets so that they are exposed to other pages or to the outside world, you could say. To do that, what we need to do is add a off-page connector or an off-page symbol. So for example, this LCD power enable, we know that this is a signal that's going to come off of our microprocessor. To add an off-page connector, go to place, off-page connector, and choose either the off-page left or off-page right. I'm going to choose the off-page left. Press OK, or you can set the name first here. Let's change it to LCD_power enable. And then I can use the R hotkey to rotate it, or again, right click, mirror, or rotate with these options. And we're going to connect it to this net. I can use this same off-page connector and copy it with Control-C, and then paste it on these nets right here. Except in this case, this would be called D_N, and we'd have another off-page connector called D_P. So let's copy those and place them here as well. I'm going to mirror. And place them on those signals. So if we don't have this off-page connector, if we had this LCD power enable net on, for example, our microprocessor page, the tool would flag an error that says these two aren't connected unless they have an off-page connector. What this allows us to also do later is to add off-page references that would say, well, this LCD power enable is actually coming from page micro in section B2, for example. And the section are named after this lettering that you see on the left side here, as well as the numbering at the top. It's basically a grid on our schematic that allows us to locate where certain objects are. All right, so we've gone ahead and created the power page of our schematic. In the next video, what we're going to do is create the microprocessor page and the peripheral page, and we'll be pretty much done with our basic schematic drawing. And after that, we'll have just one video left where we're going to do some finalizing of our components, looking at the bill of materials, and making sure that everything is ready before we're ready to export to our layout. So thank you again for watching. If you have any questions, please feel free to drop a comment or question below, and I will see you in the next video.